In this section, we have integration of rational functions by partial fractions. Method of partial fractions f of x divided by g of x proper. Number 1, let x minus r be linear factor of g of x. Suppose that x minus r power is m is the highest power of x minus r that divides gx. Then to this factor, assign the sum of the m partial fractions. So do this for each distinct linear factor of gx. a1 divided by x minus r plus a2 divided by x minus r, and here on this part power is 2, plus using 3 dots plus am, and denominator we have power is m, so x minus r power m. Number 2, let x squared plus px plus q, this be an irreducible quadratic factor of g of x, so that x squared plus px plus q has no real roots. Suppose that x squared plus px plus q power n is the highest power of this factor that divides g of x. Then to this factor, assign the sum of the n partial fractions. So do this for each distinct quadratic factor of gx. We have b1 times x plus c1 denominator x squared plus px plus q, plus b2 times x plus c2 divided by x squared plus px plus q, here power is 2, plus using 3 dots and then plus bn times x plus cn divided by x squared plus px plus q power n. Set the original fraction f of x divided by g of x equal to the sum of all these partial fractions. Clear the resulting equation of fractions and arrange the terms in decreasing powers of x. And number 4, equate the coefficients of corresponding powers of x and solve the resulting equation for the undetermined coefficients. So here on this part I have a list of derivatives of inverse trigonometric functions. So we have for inverse sine, inverse cosine, inverse tangent, inverse cotangent, inverse secant, and inverse cosecant. So if what's needed, we're going to use this page. Now example number 1, find the partial fraction, the composition for the rational expression. We have 9x plus 29 divided by x plus 3 times x plus 4. So this expression has distinct linear factors. In denominator, write the expression as a sum of two fractions with denominators x plus 3 and x plus 4. And the numerators, I use a and b. So simplify this equation by multiplying each side by LCD, least common denominator. And least common denominator is x plus 3 times x plus 4. So here I multiply both sides by LCD, x plus 3 times x plus 4, and then simplify. So left side we have 9x plus 29, and that is equal to a times x plus 4 plus b times x plus 3. Next step, we have to combine like terms. So what they have on the right side here, we have a times x, b times x, so combine these two. Here we have 9x plus 29 equal to, we have a plus b times x, then plus we have a times 4 and b times 3, so here we have 4 times a plus 3 times b. So the last equation is an identity. The coefficient of x on one side equals to the coefficient of x on the other side. So what that means, here we have 9 times x. Here we have a plus b times x. I use 9, and that is equal to a plus b. And then what's left on right side, here we have 4a plus 3b, that is equal to what we have here on this part, 29. Now we have this system we can solve. So multiply this one by -3, so I can eliminate b. So I'm rewriting that part. We're gonna have -3 times a minus 3 times b equal to -27. And we're writing the second equations. We have 4a plus 3b equal to 29. So -3b plus 3b, that part is 0. -3a plus 4a, we have a. This is equal to -27 plus 29. This is 2. So a is 2. Next step, substitute a equal to 2 into one of the original equations, either a plus b equal to 9 or 4a plus 3b equal to 29. I'm going to use a plus b equal to 9. And here a is 2 plus b equal to 9. So b is equal to 7. So what we have here, a is 2, b is 7. Therefore, the partial fraction decomposition of 9x plus 29 over x plus 3 times x plus 4 is 2 over x plus 3 plus 7 over x plus 4. Express the integrand as a sum of partial fractions and evaluate the integral. The integral dx divided by 4 minus 9x squared. To evaluate, use integration by partial fractions. Determine a and b. So what I did here, denominator, we have 4 minus 9x squared, factor that part, and we're going to have 2 plus 3x times 2 minus 3x. So this is equal to integral a divided by 2 plus 3x plus b divided by 2 minus 3x times dx. So now the partial fraction decomposition, 1 over 4 minus 9x squared, that is equal to a divided by 2 plus 3x plus b over 2 minus 3x. So LCD is 2 plus 3x times 2 minus 3x. Multiply both sides by LCD. So on left side, we're going to have 1, and on right side, this is equal to 8 times 2 minus 3x plus b times 2 plus 3x. So here on right side, I combine left terms. So what we have here is 8 times 2, 8 times -3x. So we have -3, 8 times x, and here we have b times 2, and this one is 3 times b times x. So I combined -3 times 8 times x plus +3 times b times x, and that is what I have here on this part. So I have b minus a in parentheses, and 3x is outside, and plus here we have 2 times a, and here we have 2 times b. So I factor out 2, so this is plus 2 times a plus b. And on left side, so here on right we have x. I want to have same thing on left. So, but I don't have anything on this part. What that means, that is 0 times x. So 0 times x plus 1, it's on left. So for this one to be an identity, 3 times b minus a must equal 0. So that's one. Coefficient of x should be equal to coefficient of x that we have here on left, and that is 0. So 3 times b minus a equal to 0. And what we have here, a plus b times 2, that is equal to 1. So what we have is as part 3 times b minus a equal to 0, and 2 times a plus b equal to 1. Now solving, so what I did, I multiplied the first one by 2 over 3. So that is 2b minus 2a equal to 0. And I switched order for this part. It doesn't matter, but I switched to 2b plus 2a equal to 1. So this part cancels, and what's left here we have 2b plus 2b, that is 4b, equal to 0 plus 1, that is 1, so b is equal to 1/4. And then use one of the equations to find a. So I use 2b minus 2a equal to 0, and b is 1/4. So solving for a is equal to 1/4. So we have the same answer for a and b. And then integrate each term. Here we have integral a over 2 plus 3x plus b over 2 minus 3x times dx. And here instead of a and b we have 1/4. So I used 1/4 for a and 1/4 for b. Next step, so what I did here on this part, I multiplied this one by 3 over 3. So on top I multiplied by 3, and here denominator I did same thing, so 3 times 4 is 12. Why I did this? Because I wanted to have derivative of 3x on top. So derivative of 3x is 3, and this way when we try to find integral, the answer will be natural log absolute value of 2 plus 3x. Recall that derivative of ln or natural log, here variable is x, that is equal to 1 over x. So derivative of that part is 1 over what exactly you have here on this part, so writing that in denominator. So this is same natural log 2 plus 3x. When you try to find the derivative of that, that will be 3 over 2 plus 3x. So this is exactly what we have here on this part. And I did same thing for what I have here. Here I have 2 minus 3x. Negative 3x prime, that is, the derivative of that part is negative 3, so that is here on top. So to have that one, I multiply numerator denominator by negative 3. So negative 3 times 1 on top, and negative 3 times 4 in denominator. So I have negative 3 here, and negative 1 over 12 here outside of integral. So for that part, integrate that part, we're going to have negative natural log as a value of 2 minus 3x, and then here I have constant, so plus c. So this is our final answer for this part. Express the integrand as a sum of partial fractions and evaluate the integral. So with this given integral of 4s plus 4 divided by s squared plus 1 times s minus 1 cubed times ds. To evaluate the integral by partial fractions technique, express the integrand as as plus b divided by s squared plus 1 plus c over s minus 1 plus d over s minus 1 squared plus e over s minus 1 cubed. And then find a, b, c, d, e, and integrate with partial fractions as integrands. So in this case, we have to multiply both sides of the equation, but the least common denominator. I multiply both sides by LCD, and what we have here on left, it's 4s plus 4 equal to, on right side, we have as plus b times s minus 1 cubed plus c times s squared plus 1 times s minus 1 squared plus d times s squared plus 1 times s minus 1 plus e times s squared plus 1. So next step, expand the polynomial. So what we have on right side, I multiplied all these, and then I combined like terms. So for s plus 4 is equal to a plus c times s to the 4th power plus b minus 3a minus 2c plus d times s cubed, 3a minus 3b plus 2c minus d plus e times s squared plus negative a plus 3b minus 2c plus d times s power is 1 plus negative b plus c minus d plus e. So I combine like terms, and then so what we have on left side is 4s plus 4, but here we have power 4, power 3, and power 2. We do not have these powers on left side. That means that for these we have 0. So we have 0s to the 4th power plus 0s cubed plus 0s squared plus 4s plus 4. So based on that, what we have here, a plus c, here we have s to the 4th power, and on left side we have 0 times s to the 4th. So a plus c is equal to 0, and then for this one we have s cubed, and we don't have x cubed here on left, so that means again on this part we have 0 times s cubed. Again, here we have 0 times s to the 4th power plus 0 times s cubed plus 0 times s squared plus 4s plus 4. So on this part we have 0. b minus 3a minus 2c plus d is equal to 0. Then this one is s squared. Again, we don't have s squared on the left side, so we're going to have 0 here on this part. So 3a minus 3b plus 2c minus d plus e, that is 0. And now this part, here we have s, and we do have s on left side, and coefficient of s is 4. So negative a plus 3b minus 2c plus d is equal to what we have here, equal to 4. And finally, negative b plus c minus d plus e is equal to this one, and that is 4. Now integrate. So integral for s plus 4 divided by s squared plus 1 times s minus 1 cubed times ds, that is equal to, based on what we had here on top, and what our answers are for a, b, c, d, and e. We can integrate this part. So first, enter all these into calculator and solve for a, b, c, d, and e. So these solutions are a is 0, b is 2, c is 0, d is negative 2, and e is 4. So use these here on top. A times s plus b. So we have 0 times s plus 2. So this is 2. And then c is 0. I don't have that part. Then we have plus d. d is negative 2. So negative 2 times ds divided by s minus 1 squared plus, then what we have here is e, and e is 4. So I used 4 for e, and then integrate. So integral 4 times ds divided by s minus 1 cubed. So integrate 2 ds divided by s squared plus 1. That is 2 times inverse tangent. So recall that what we have for derivative of inverse tangent, that is equal to 1 over 1 plus x squared. And what we have here on this part, we have s squared plus 1, denominator on top. If I use 1, so let's assume that here we have 1 times, so that is 1 times 2 divided by s squared plus 1. I factor this 2 from all of these, so factor of 2 here is 2, we have that one outside, and 1 over s squared plus 1, integrate that part, that is inverse tangent s plus, so we factor that part, and here we have negative 1 over s minus 1 squared, so integrate that, that is 1 over s minus 1, and here on this part, so we factor out 2, we have 2 over s minus 1 cubed, and integrate, that is negative 1 over s minus 1 squared, plus c is constant. So this is our final answer for this one. Perform long division on the integrand, write a proper fraction as a sum of partial fractions, and then evaluate the integral. integral to x cubed minus 4x plus 5 divided by x cubed minus x squared times dx. So in this case, the order of the numerator is not less than what we have in the denominator. So use long division to get a quotient qx and the remainder rx. So based on that, we're going to have f of x dx equal to qx dx plus rx over fx times dx. So quotient is qx, remainder rx. So we're going to have fx dx equal to qx times dx. So this is when we divide as fraction. So 2x cubed minus 4x plus 5 divided by x cubed minus x squared. So again, fx times dx equal to qx dx plus rx divided by fx times dx. This means we want to have integral fx dx equal to integral qx dx plus integral rx over fx times dx. So based on that, after dividing, what we're going to have for qx, that is equal to 2, and remainder is 2x squared minus 4x plus 5. So our integral is equal to integral 2 dx plus integral 2x squared minus 4x plus 5 divided by x cubed minus x squared times dx. So this part, it's easy to integrate. That will be 2x plus c, right, for this one. Use partial fractions. So 2x squared minus 4x plus 5 over x cubed minus x squared, that is equal to, so based on what we have here in denominator, x cubed minus x squared, that is x squared times x minus 1. Here we have power is 2, writing powers in decreasing order. So we're going to have x to the power is 1, then x squared, then x minus 1. So we're going to have all these in the denominator. So I have x, I have x squared, and I have x minus 1. Then I multiply both sides by LCD, which is x cubed minus x squared. So both sides multiplied by that, and then simplifies here. Here on left side, we're going to have 2x squared minus 4x plus 5 equal to ax times x minus 1 plus b times x minus 1 plus b times x squared. Combine like terms, so here we have, on the right side we have a plus d times x squared plus b minus a times x minus b. If it's hard to write these, it's better to first multiply what we have here. So ax times x, ax times -1, b times x, b times -1, and then combine like terms. Now find a, d, b. So what we have here, a plus d, that is coefficient of x squared, and here coefficient of x squared is 2, so this is equal to 2. Then we have b minus a, that is coefficient of x, and here coefficient of x is -4. And finally we have negative b equal to 5, or b is equal to -5. So based on what we have here, b equal to -5, use that one here. On this part, we have -5 minus a equal to -4. So a is equal to -1. And then finding d. So a is -1 plus d equal to 2. D is 3. So we have all these here. So integral is equal to, we had integral 2 times dx plus, now for second part, we had this one. So we have a over x. A is -1. So integral -1 over x times dx. Then b is -5. So negative integral 5 over x squared dx plus integral d is 3 divided by x minus 1 times dx. Now integrate, here we have integral 2 times dx, so that is equal to 2x. For this part we have negative natural log absolute value of x. So how I got this one, derivative of what we have here, that is 1 over x, and here we have negative. And then we have negative integral 5 over x squared. So integrate that part, that is positive 5 over x. Here again we have natural log, so integrate 3 over x minus 1, that is equal to 3 times natural log absolute value of x minus 1, and then add constant. So here's final answer for this part.